Hi, I'm Adi Arun, and I have created a course where you'll be taken through the perplexing algorithmic journey of creating a complex 2D version of the game Minecraft with Flutter and a bare bones game engine package Flame. This is a jam packed, all in one 24-hour long course made with 600 hours of dedicated work, which will leave you well on your way to becoming a better developer. In this course, we'll cover every prominent feature that makes Minecraft the game it is, including procedural terrain generation with Perlin noise, biome generation for deserts and birch forests. This is of course expandable. Structure generation for trees, cacti, flowers, etc. Chunk rendering and unrendering logic. Dynamic crafting algorithms. An intensive inventory storage algorithm mirrored on a versatile inventory UI, day-night time cycle paired with a parallax sky, hostile mobs including zombies, spiders with their own AI, a large arsenal of tools and weapons with specific functionality, gravity blocks like sand, world saving with Hive, an interactive launcher for creating worlds, and much more. All of these complex features and code are packed and explained line by line with captivating animations. But this is not it. You can expand on my take to Minecraft, as this course was designed to encourage your creativity. If you have any problems while coding, you can reach out to me on my Discord server. Flame. What even is it? It's basically just a game engine that we can use to make 2D games in Flutter. To install it, you simply add it in the dependency section of your pubspec.yaml file, just like any other package. For this tutorial, we'll be using Flame version 1.1.1. To make a game, we first create a game class where we will inherit from Flame game that Flame provides for us. This gives us the ability to add components to our game. A component could be anything from a player to a sky. A component is to Flame as a widget is to Flutter. Almost everything is made up of components. Now, you may have noticed that we can't directly use main game to run our app. This is because it's not of type widget. So let's convert it to a widget by using the gameWidget function. And now to make a component, we first create a class that extends from sprite component. And each component has an asynchronous function called onload, which gets called at the beginning of the creation of the component. And this is also present in the parent, so we have to override it. And also called super.onload, because we also want the function inside the onload of the parent to execute. And now we'll actually define the sprite that we want a component to use. And as we know, a sprite is just a 2D image. So we'll just provide in a 2D image here. Notice how the path here is incorrect, because the actual path should be assets/image/sprite picture.png. And this is because sprite.load automatically looks inside the assets/images folder. And right now we don't have a size for this component, so it won't appear on the screen. Let's give one. So size equals vector2 100x and 100y. Vector 2 is just a measure of x and y. So this basically means our sprite will be 100 pixels in width and 100 pixels in height. Okay, so this is it for our player component. And now we want to actually add this to our game. To do that, we'll go into the onload function of the main game. And we'll call the add method and pass in the player component. If we run this, we can see it here. Our component has loaded.
Just like the onload method, there exists other methods inside our sprite component that we can use for different functionality. One of such methods is the void update method. Whatever is inside here gets called each frame of our app. The void update method takes in a double DT, which is basically the amount of time between each frames, or the FPS. Now let's put position.x plus equals 10. Position is a vector 2 inside of a sprite component that basically determines the player's position, And we're changing the X value of the position by 10 pixels each frame. So if we run this, we can see that our player moves to the right. Another important method is the on-game resize method. This gets called every time the screen size changes, as well as at the beginning of the creation of a component. Here we get the new screen size, so we can change the size of a component to something responsive. If we divide the vector 2 of a new screen size by 10, we get a new vector 2 of 1/10 of the x and 1/10 of the y. This also means we can remove this from here since the on-game resize gets called at the beginning of the creation. So if we reload this and resize it, we see that the size of a component also gets resized.
Now that we have a basic understanding of the Flame engine, let's start setting up our project environment. First of all, you are required to have the Flutter SDK installed and VS Code. Now let's open up command prompt by typing in cmd. We're currently not on the desktop, so let's migrate to that. Before doing anything, let's actually check our Flutter version. The current Flutter version is Flutter 3.0.1. If you haven't upgraded to this, it's completely fine, since we won't be exactly using anything specific to this. But if you want to follow along, either you can downgrade or upgrade to this version. Let's create a Flutter project. Flutter create Minecraft. And let's also provide in a package name. What is a package name? The package name is a unique identity for our app. The default package name usually comes in conflict when you're publishing your app. So how do you actually change it? You can do it by doing --org, then giving a prefix. I'm going to give adiarun.app. You can give yourname.app. Now our new package name would be adiarun.app as a prefix. So adiarun.app.minecraft or your project name. Let's enter. Now let's migrate into that folder, cd Minecraft, and let's use this command code space dot to open this project in VS Code. First things first, let's go up to source control here and then check off source control. You might not have that, but if you do, just check it off. Inside libs, we have our main.dart where we'll be doing our coding. Here's the boilerplate code. We don't actually need this. Let's delete it altogether. You can keep some of it if you'd like. In the pubspec.yaml file, let's start adding our dependencies. As we know, one of our main dependencies is the Flame engine. So under Cupertino icons, let's add Flame. Version 1.1.1. Now here we have our assets. Our assets will be all of our images that we use. Images, it's not specific to images. It could be fonts, it could be videos or anything. To get our assets, you'll have to go to my GitHub repository that I have linked here. So to download this, click on code and download zip. Now let's click on this and unzip it to our assets folder. Currently, we do not have an assets folder, so let's create one. Assets. And let's copy path. Go back here. Extract to. And then let's change this path to our assets path. And click on enter. Now, as we see here, we have 3 new folders: controller, fonts, and images with lots of subdirectories. And now, right now, let's define our assets. So Let's actually just type in assets for now. Whatever we put in here it'll only look in a direct directory sense. For example, if we put the path here as assets slash images slash GUI, it'll only look what's inside here. Meaning, if we had a folder here, for example, other GUI stuff, it wouldn't look for the images inside here, which would mean we have to define all of the subdirectories. Let's do that. And we have, okay, so we have mainly 3 assets branches. So let's actually put a cursor here and then click on Shift Alt. Let's have that held down, Shift Alt, and then let's click on the down arrow key. And we'll do that again. This will duplicate the line to the next line. So here we can add controller, fonts, images. Controller and fonts do not contain subdirectories, so let's ignore that. Okay, now we have images, which has again 5 different subdirectories. So let's duplicate it down 5 more times. Shift Alt down arrow key. Okay. GUI. Now next is inventory. Then launcher. Parallax. And sprite sheets. You can look into these folders if you want. These are just the images that we're using. Okay. So as you can see here, GUI, inventory, launcher. These 3 folders don't contain subdirectories, so it's fine. But then parallax does. It has 3 different directories. So let's click on here, asset slash images slash parallax, and then duplicate it down. Shift Alt down. Okay. Evening, morning, and night. Same with sprite sheets. 1, 2, 3, 4. Blocks, item, mobs, player. Actually remove this. Okay, that's it. Now you might have noticed this fonts directory here. This is the font file that we'll be using. That will give us our Minecraft font. So let's select this and click on Control /. Let's delete all of these. We want this name, the name of our font to be Minecraft font. You can name the same thing you like. And here, let's just provide in our path. So copy relative path and add in here. Now you can either run Flutter pub get inside your terminal or just save it, which would automatically run Flutter pub get. Okay, Flutter pub get has done running. Now let's code in our main dot. Let's actually delete our test folder right now because we won't be doing anything with it. Let's import material and then go into our void main. Here we are going to do run app, and then here we'll put in our game widget of our main game. Before creating that, we need to actually ensure that Flutter is completely initialized before running. We can do that by doing widgets Flutter binding ensure initialized. This is not a future, so you don't have to await it. Yeah. Now let's create our main game class as we know. Let's do main game. And our main game class will extend from, let's actually first call it main game. It will extend from flame game that flame provides for us. Flame game. Let's not have anything now. This is our main game. We will add all of our components here. Okay, now as we know, we cannot directly add main game here since it's not a widget. Oops, not that. Main game. So you're gonna have to turn it into a widget. We can do that with the game widget. Here, let's just provide in main game. Yep, that's done. Now we can either run this by going and run start debugging or run without debugging. I usually like to start debugging to run it. We'll be building this in Windows for now, but you're free to choose any other version, any other platform, I might say. So let's run this. I'm gonna click on F5. Okay, so our Windows are built. Before we start doing things in our main game, we need to dig a little deeper into the composition of our game screen. The game screen will consist of two parts, the main game and a static HUD or a GUI on top of it. You know, the thing with the inventory, health bar and such. It's fairly easy to implement this. We'll basically just make a game layout which will be a stack widget, where the first child will be our main game widget and all the other widgets are HUD widgets. So now let's create the game layout with controller buttons in the HUD. Okay, so let's start by creating a folder inside libs called layout. Here we'll have our game layout and all of the widgets that will consist of the HUD. Alright, so let's create a file, game layout.dot. Let's import material. Okay, now let's make a stateless widget. We'll call this game layout. And let's return a stack. Okay, the first widget in the children is gonna be the game widget to our main game. So let's actually cut this from here and paste it here. Let's import these. Cool. It's actually comment here. So this is the main game. Everything coming here will be in the HUD. Alright. Cool. Now let's create another widget, another folder called widgets inside our libs. And in this folder, we'll have all of our widgets. And one of the widgets that we're gonna make right now will be the controller widget. These here, we have a center image button, a left image button, and a image of a right button. Cool. So let's create a file. Let's call it controller button widget dot. Let's import material again. This time we'll make it a stateless widget because we want the state of the button to change every time we click. Once state, actually a stateful widget, yeah. So controller button widget. Now we have a state and we're going to return a gesture detector. So so if we wrap widget X around a gesture detector and we click anywhere or do any action here, like a double tap cancel, these are all the events we can access. We can actually like know if the widget's been pressed or something. We'll be using a function here called on tap. Let's log this widget has been pressed. Right, now let's have the child. For the child, we'll have an image widget with the path of our controller. Yeah, so we're gonna actually take the path from the constructor. So let's do final string path and we'll require this. Okay, and oops, required this dot path. And for the widget here, we're gonna give path here, we're gonna give widget dot path. All right. Now let's also give width and size for this. To make it responsive, let's say the width should be 1/17th of the screen's width. Okay, so it'll be responsive. So first we need to get the screen's width. To do that, let's first create a screen size variable, and we're gonna use media query to do it. If you didn't know it before, media query allows us to get the screen size. So context dot size. So now we have the screen size, and now we can access screen size dot height, screen size dot width, or whatever we want. So here, let's we'll put this around a size box, and we'll actually give the size to the size box. So height 1/17th of the screen's width, right? So screen size dot width divided by 17th. Same for the width, because we want it to be a square. Screen size dot width divided by 17. Let's format this. Okay. Now inside layout, let's create another file, controller widget dot import material again. This time it'll just be a stateless widget. And the controller widget is just going to be a row of controller button widgets. So we basically just have a row with a controller button widget with the path to the left button, then the center, then to the right button. So yeah, controller widget. Let's return a row. And here, children, of course. And let's okay, so controller button widget. Let's copy the path here. So copy relative path. The relative path will be the path relative to our folder. So assets slash controllers slash left button.png. Okay, now let's repeat this. So let's hold shift and alt and then click the down arrow key twice. Okay, now we have duplicated it, and we'll just change the last path here. So button, center button and right button. Cool. Right now, to avoid the constant issue, let's just mark the whole list as constant. We're gonna change this later, but then temporarily, let's just do this. Okay, now let's go back into our game layout and then add the controller widget. Nope. Let's save everything first. Cool. Okay, controller widget. Make this constant. Right. Now in the main, let's just run app, not the game widget, the game layout. So we'll get a stack with our game widget and the controller widget. Cool. So let's save everything and debug this. Okay, so we've got an error. Alright, so this is because we don't have a material widget in our app. Now do we? We're directly using run app to, and sending our stack here. So that's a problem. So let's just go here inside main and do material app. For the home, let's pass the game widget. This is the same. It's gonna be the same as everything, but we actually need a material app, right? So let's see. Okay, that works. All right, now let's optimize this. We need a little bit of padding, and we want this to be at the bottom left of our screen. So first, let's go into the controller button widget. Here, okay, let's wrap the gesture detector, okay, around a padding. And let's make edge inset symmetric, horizontal 20. This means that there'll be 20 pixels of padding to the left and right of our widget. Okay, let's save this. Let's see how that looks. Okay, that looks fine. And now inside, let's close these. Inside a controller widget. Okay, so how do we actually position to the bottom left? Either you can wrap it around a stack. So actually, okay, right, look. So this okay, where's the game? Okay, yeah. The controller widget is inside a stack, which means that we can use a positioned widget to control its position inside the stack. So there's two ways to do it. One is simply by doing positioned and bottom 0 and left 0. This means that 0 pixels from the bottom and 0 pixels from the left. Yeah, that works. Or another way to do it would be to do position dot fill and removing these and wrapping the row around an align widget, and then giving the alignment to the align widget as alignment dot bottom left. I personally like to do it this way, so we have the same result here. And now let's give it a little bit of bottom again, or I guess it would be cleaner to just do it this way. Whatever works, it's your preference. So in the bottom, we're gonna give 100 pixels, and we need a little bit of padding in the margin in this case to the left too. So let's do left 20 pixels. Let's see how that looks. Okay. Now, right now it might look that, it looks a little bit odd because, it's way too high up there. We want it to be a little bit down here, but we're soon gonna be having an inventory here, so that'll be fixed. Cool. Now we actually, okay, let's go into our debug console. And these errors are being caused by, it's just some bugs that are occurring in the new Flutter version. Yeah, so let's just click on any of these buttons and we see this log here. This widget has been pressed. Okay, let's go back to our controller button widget. You could have also used print here, but it's, we get a static analyzer check here. Avoid print calls on production code. So it's always cleaner to just use log. All right. But now we don't want to define the on tap in the controller itself. We want to get the on tap from the parent, like just as we do it in the button. Like, let's say we have an elevated button, elevated button, and it's non-pressed, right? So if you click on it, something's gonna happen. To do, to get a function, to get a parameter like on pressed, we can use a thing called void callback. So final void callback on pressed. Let's require this in a constructor, comma required this dot on pressed. So now we get these errors here because we haven't provided the on pressed. So the on pressed is just going to be like a function like this. You can do stuff here. Okay, so now is the time to remove the const from our list, right? So yeah, we can pass a function here as a parameter. So let's do log left button pressed. Let's actually copy this, paste it, comma here. Actually copied again with the comma. Right button pressed. And okay, cool. Let's actually, there's too many brackets here, so let's remove some. Okay, right. So left, actually this is the center. Oopsie, my bad. Center and right button pressed. And in the controller button widget, let's change this and do widget dot on. Okay, not that widget. Let's see. Just widget dot on pressed. Right. Let's save hot restart our app. Go to the debug console. And let's okay. Oops. Left. So left button pressed, center button pressed, and right button pressed. Right, we'll eventually use this to control our player. That's it for this one. Now we want the opacity of this button to change when we actually click on it. How do we do that? Now there's a we are in a controller button widget. Okay, there is a widget called opacity widget. It's actually wrap a sized box around it, opacity, and we need to provide an opacity double. So let's put 1. 1 means full opacity, so we should see nothing change. Yep. Let's try putting 0.5. Now the opacity would be 0.5 of that opacity. It just looks a little bit darker because our background is just black. I swear it's the opacity that's changing. All right. Now we could do something. Okay, while the cursor is held down, we want the opacity to be lesser than the current opacity. And while the button and while the mouse click, when the tap up happens, we want the opacity to go back. So let's first define some constants. Or let's just do, okay, first we'll have a bool, okay, is pressed equals false. Okay, if the button is pressed, we want 0.5 opacity. If not, 0.8 opacity. Okay, now we'll set state is pressed to change when the player, when the user is clicking the button down. So let's actually not use an on tap. Instead, let's use an on tap down. This will execute, just when you hold the button. Okay. So on tap down. We get an argument here. We don't need that. So we'll do set state is pressed equals true. And we also want to run our on pressed function. So let's do widget dot on pressed. Right. And then, okay, let's see what happens now. Let's save this. Okay, we see that nothing changes. This is because we have is pressed defined inside the build. To actually do this. Okay. Now when we tap down on it, it changes the opacity, but then we want it to revert back to its original state. So let's do on tap up, unused argument, and we're going to set state is pressed to false. Okay, so when you click on it, the opacity changes. Now, in the debug console, we don't see the actual function printing. We had set up logs here, left button pressed, center, right pressed. That's not appearing. That's because we forgot to put brackets here. Now if we restart our app, and click on these. Okay, it works. Now let's create the player. So far, we have briefly discussed on how we can add a simple component to our game as a 2D image sprite. But how do we actually create animated sprites? It's actually really easy. We'll use sprite sheets. A sprite sheet is simply a collection of sprites. We can use our player sprite sheets to create different play animations by using a method Flame provides for us. Okay, now just as we did for widgets, let's create a new folder for components. All of our components are going to be here. So let's create a player component dot. And as we know, a component is just a class that extends from sprite component, right? Let's do class player component extends sprite component. And each component has a asynchronous onload function that gets called at the beginning. And that's where we, define the sprite, the size, the position, all the, things that actually initializes a component. So let's create that. Future void, because it's asynchronous and it doesn't return anything. Onload, it's async. So super.onload, because we actually don't want to, override the onload of a parent completely, but we want to override it and also make sure that the programs inside there is executed correctly. Let's say we had a vital program running in the onload of our parent and we just override it and forgot to call super. Maybe that function doesn't get executed and maybe it breaks a game in the future. So yeah, so super.onload, and here we're going to define our sprite, right? So how do we do an animation with a sprite sheet, of course? So we'll create a sprite sheet just like how we initialize, any class. So sprite sheet, let's call it player sprite sheet equals sprite sheet. Okay, so as we see here, we have, two parameters, image and src size. Let's ignore this for now and let's focus on the image. What is the image? The image is like, just the image. We have to load the image in. It's of type image, right? So we cannot just give it a path or anything. Like, let's say we wanted this sprite sheet. We want to create an animation with the sprite sheet. So you'd think you just copy relative path and then paste in the path here, but that doesn't work because we need of type image. So to load an image, just like our flame wants, we'll do flame dot images dot load, and now we'll provide our path. Let's rectify the path, and all right. So again, flame.images.load automatically looks inside the assets/images directory. So we don't really need to have this right here. Cool. And this is also an asynchronous function. It's a future, right? So we have to call await on it. All right. Now, okay, let's see. Okay, yeah. How does a sprite animation exactly work? So sprite sheet divides our image into different grids based on the src size. Okay. For example, the size of a player here is 60 pixels by 60 pixels. So we would give the src size as 60 pixels by 60 pixels. So one grid would be this, another would be this, another would be this. It'll automatically divide our sheet based upon the src size. And then when we call a create animation function, it's basically just going to take this sprite and then after a period of time switch to the next grid and then to the next and then repeat it all over again. Right, so that is the src size. So the src size is basically what we want the size of our grid to be. In our case, it's 60 pixels by 60 pixels. So let's do vector 2 because it's of type vector 2. And vector 2 is just a measure of x and y. So we can just put 60 and 60. Like you can access the x with the vector 2 or the y with the vector 2. It's very handy. That's why we're using vector 2 here, or at least why Flame used vector 2. And there's actually another way to do it. We have defined vector 2 as 60, 60. There's actually a factory function called vector2.all, where if you just provide one value, it'll create a vector 2 with the x and y as 60. So I guess this is a little bit more cleaner. Right, we have a player sprite, not a sheet, a sheet. Now we need to create an animation from this. How do we do that? We'll do player sprite sheet dot create animation. Just like I said, it basically goes into a grid. Okay, here we have two grids actually in the y. We have two grids in the y because this is 60 pixels and this is 60 pixels. How do we know what row to use? So we specify that here. Like if we said, bro, do the sprite sheet thingy in the first row, or hey, yo, do it in the second row. So we do it like this. And of course, since we can't count from 0, this is 0 and this is 1. Right. And then the step time is a time interval between the animation. Okay, like the time it switches between this grid to this grid. So and it's in seconds. So right now let's give something like 0.5 seconds. Right, but we have an error. The value of type sprite animation can't be assigned to a variable of type sprite. That's because create animation returns an instance of sprite animation. And a sprite is obviously just a static 2D image. So how does that work? To do it, we actually have to change sprite component to a sprite animation component. This allows us to actually add an animation into this. So, but a sprite animation component it's just exactly everything except one part. Is just think about it, like everything is similar to a component, just like everything is the same as sprite component. It's just that the sprite part, or what we actually see, is different. So we can just change animation to this. This is the same as doing sprite equals sprites dot load image path. The same as doing this, but this actually supports animations, whereas sprite is just a 2D image. And now we need to actually add this into our game. To add this into a game, we'll again go into the onload of our main game, because we do all of our initialization stuff inside the onload function, and each component does have one. So that also means the Flame game also has one. So let's create the onload, override future void onload async. It's also called super. And to add this component to our game, we simply use the add method and then pass in an instance of our component. So play component. Right, let's hot restart our app. But we don't see anything. That is because we didn't actually give a size for our sprite. Last time when we actually just used a sprite component, just after defining the sprite, we also did size equals vector to something, because it defaults to nothing. So right now our sprite is technically there, it just doesn't have a size. So let's give it a size equals, and size is of type vector 2. So vector 2, and let's just say 100 pixels by 100 pixels width and 100 pixels height. Let's save this. Cool, so that works. Right. And right now we're using the row 0. Here we have, as I told, we have two grids in the Y. The 0th grid is this one. So if we change it to the first grid, or the first row, we get this. This is the damaged player sprite sheet. So we have an animation here. And let's also try it with another sprite sheet, like this one, a player walk-in sprite sheet. Here we can change just the idle to walking, and then the row back to 0. Let's save this. Okay, as we see here, we also have this animation here, and we can change the step time to something smaller so that the animation happens faster. Cool. And now to prove it to you that it's just like any other component, and the only thing that is changed in sprite animation component is the animation. The sprite is just swapped with animation. I'll create a void update function. As we know, this gets called each frame of our app. So super.update. So here we'll just change the position. So position equals position.x plus equals 10. This would basically just make our player move to the right, because the flame graph is like a graph starting here. The y value is 0 here, and the x value is 0 here. The top left is 0, 0. As we move further down, the y value changes, and as we move further right, the x value changes. Right. And we can also prove that. Let's do position.y plus equals 10. So it's moving diagonally now, because it's moving at both the y value and at the x value the same rate. Before we proceed further, let's think about how we're going to manage data of each individual world. Our main game is going to be building the game based on our stored world data. Our world data will contain all information specific to that world, like the player data, inventory data, time, world chunks, etc. So we will create a world data class with all of these specific world data, which the main game will require to build the world. Now, since world data is going to be something global to our game, we're going to create a new folder called global, and creating a new file, world data dot, and we'll be putting a class here. So let's create the class world data. Right now we won't have any kind of data inside this, but soon we'll create different classes like player data, inventory data. All of these data will be like stored somewhere, which we are going to load, and then we're going to pass that world data into our main game. Right now, the main game doesn't do anything in regards of interacting with the world data. So let's actually take on from our constructor. So world data. So, and then you'll require this from a constructor. So require this dot world data. So right now we're just going to be passing an instance of the world data, but then eventually we'll be loading this world data from a launcher. We'll eventually create a launcher where we'll click on some kind of widgets which will load that specific world's world data, which we're going to send to the main game, which will render the game for that specific world data. Okay, now inside global, let's create a file called player data dot. This will be a class called player data, and here we'll have all of the player data like health, hunger, state. The state will be like walking left, walking right, idle, or whatever. So this is specific to a world, right? In a different world, you would have different health, hunger, state. So inside main game, actually not inside main game, inside a world data, we'll be adding this. So player data equals player data. Okay, right now we're initializing player data like this, but eventually we'll be getting an instance of player data from our storage.
but right now we're just doing like this for simplicity. Okay, so inside player data, let's create a component state. Something like component state does not exist. We're gonna make it up. It's gonna be an enum. So component, let's say motion state, and this enum will have walking left, walking right, and idle. Right now, if you don't know what an enum is, it's basically, I mean, we're going to be using it to compare values. Let's say when you click the left button on the controller, current held down option. Okay, let's say if you click on the left button of the controller, the current held down option will be turned into component motion states dot, we can't actually do it here. Okay, component motion state dot walking left. If you clicked on the right button, it would get changed to component motion state dot walking right. So we can just check it here. So if current held down option equals to component motion state dot walking left, just move player to the left. So we can just use it for comparing things. That's why we're using enums. So inside player data, let's create component motion state. Component motion state equals, let's initialize it to be, you know, not doing anything. So idle. I mean, these values mean nothing now, but we're just initializing it to be like this. Right. Now we have it inside world data too. And I talked about a communication class, a class where you can access everything in the game. So let's say we made the global instance class to be the world data. Well, if we made it to be the world data, we could access most of the things inside our app. I mean, inside a game or a world data, right? We'll be able to access everything here. I mean, right now there's nothing here. There'll be the inventory data, chunk data, you know, and time data, everything like that. But there's more things to our game. Like maybe we have a player here, you know, like a player instance. We have some constants here. I mean, some constants like speed or something here. So a good way, we'll use the most, you know, parent most class as a global instance. World data isn't a most, you know, parent most accessible class. It is the main game. What that means is if we have a global instance of main game, we'll be able to access everything inside world data, because you know it's a field inside main game, and everything else that we're gonna eventually define here. So that's why we're gonna make the global instance to be of main game. First, to create global instance, create a global instance, you're gonna have to go to pubspec.yaml file right here, into your dependencies, and here we will add our package, which is get. Let's save this. Let's save this, or just run flutter pub get in our terminal. Okay, it's done running. Now, you know, you could easily just do, okay, now to get a global instance, you do get dot put, then main game, and then let's not do anything here. So get dot put main game. But again, this is not possible since we have to provide in a a world data, and then it's kind of tedious to type all this out. So let's actually create a class inside global. Let's call it global game reference. That would just mean, you know, we're referring to the main game. You can call it anything you want. This is quite a complicated name. You're free to choose whatever you want, actually. So yeah,
So let's create the class global game reference, and this will have an instance of main game. So main game, or let's actually call it game reference, right? And we late initialize it, meaning we won't exactly initialize it right now, but at some point during runtime we will initialize it in our onload. If we did game, let's do global game reference. Let's say okay, let's have this one here, global game reference. Global game reference equals global game reference, and let's do global game reference dot game reference equals this. This is it, pun intended. It this basically just saves an instance of this current instance. I mean, it saves the current instance inside global game reference. But this is actually quite counterproductive because this is not the global instance. This is just a random instance that we're doing here. So let's do get, as we talked about before, get dot put global game reference. Now we are actually adding an instance of this to the global game reference, which means that even if you were inside widgets and somewhere here, and if you did get dot put global game reference, you could still access, you could still access, I mean, global game reference, dot game reference, you could still access everything here, because you actually saved the instance to game reference here. So now we can use it here. So yeah, but it's kind of, tedious to type get dot put global game instance. So let's go in here and then create a static function. A static function is a static method, should I say, is a method that you do not need the instance of a class to access. That sounds very complicated, but I mean, it's not, I swear. So let's do static void instance. Static void get instance. This will be a getter function. We're gonna return the global instance. So get dot put global game reference constant. Yeah, actually that's it. So now, rather than doing get dot put global game reference dot game reference, we could just do global game reference dot instance dot whatever we want here. Yep, but we did a mistake. I didn't mean void here. I meant we're returning a type of global game reference, right? So we're gonna return type of global game reference. So we have a global instance here. So once initialized from our main game, we'll be able to use everything here, and in a global perspective and not just an instance of it. If we could change, let's say we have a string something here, we could change the value of this string inside a controller, like the actual value and not just the value of an instance. So yeah, so we have that ready. Okay, now let's actually change player component state. Actually, okay, let's go back to our player data. Okay, here we have a player component state, component motion state, which is idle now. Now let's actually make this useful. So inside of our player data, actually not a player data, inside of a player component, we will make a function that does, if the component state is currently idle, do nothing. If it is walking left, walk left. If it is walking right, walk right, or move right, or whatever. So we'd have to constantly check this every frame. So you know what that means. This is going to be inside of a void update function. So double dt. We also need to call super.update. All right. Now here, let's check if Now if what? We need the component motion state, but how do we actually get that? I mean, we can easily get that from game global game reference dot instance dot game reference dot, yeah, now what? That is okay, world data dot player data dot component motion state. Oh my god, that was so long. So we actually have to, let me break this down for you. Global game reference dot instance dot game reference is just pointing to a game reference, and this is basically now, it's like we're inside of our main game. So we can access our world data, and world data has a player data, and inside the player data we have a component motion state. Right. Now before doing everything, let's actually go back into our main game, and here we're just adding an instance of player component. Let's change that. Let's actually do okay, let's do player component equals player component, right? And now let's do player component here. So this basically doesn't change much, but you'll eventually see what difference that makes. All right. Now inside here we have global game reference dot instance dot game reference dot world data dot player data dot component motion state. That was so long to say. All right. Now we'll check if it is component motion state dot walking left. If it is walking left, you know what to do. How do we actually move a player to the left? We've gone through this before. We'll just do position, which is our current player position, dot x. If we add 2x, it's gonna move to the right. So we'll subtract from x. So position, we need to change the current position. So position dot x minus equals to let's actually define final int, actually final double speed equals 10, or let's do 5. So minus equals speed. This dot speed, actually I spelled that wrong, but let's ignore that. Okay, it's SPPED. All right, my bad. Right, so moving left. Now let's do else, not an else if. Let's just do another if. Let's copy all of this. If the global game reference or instance, okay, if the component motion state is walking right, let's walk right. So position dot x plus equals speed. Right. So increasing our x is going to the right, decreasing is going to the left. All right. Now all we have to do is change the global game reference. Our player data's component motion state. So let's go into a controller widget. Here we'll change the on pressed. So if the left button is clicked, let's do game reference. Oh my god. Global game reference dot instance dot game reference dot world data dot player data dot component motion state equals to component motion state dot walking left. Let's copy all of this. Okay, let's actually create an instance of this. So player data equal player data equals this abomination. So now we can just do player data dot component state equals component state dot walking left, or yeah, okay, that's fine. And let's copy this inside here. Let's do player data dot component state equals player data dot walking right. Now let's save everything and then run. Okay, we've got an issue here. Late initialization error, field game reference has not been initialized. Okay, so let's go into our main game. Okay, so let's actually not initialize this right here, but let's initialize it in the constructor of main game. So we could just do this game reference. So, this happens at an earlier moment in runtime than when the onload is called. So let's run this again. Hot reload our app. Okay, it's working. Right, so as we can see here, let's actually close our widget inspector. We don't really need that. As we can see here, the global game reference has been created. So yeah, so this is a message that we get from getX. So yeah, it works. Now let's click on this. Right button pressed. Let's go back to our controller widget. Let us see. Oh, okay, my bad. We actually changed the on press of the center jump button actually. So let's cut that and paste it here. Let's save it. Cool. Let's click on right. All right, it's moving right, and now left. Okay, our player is moving left and right, but then we can't control it. Once we click it, it's always set to moving. So let's actually pause this right now, because we don't want our player wandering into infinity. Okay, so let's go over everything that's happening now. Right now, in the beginning, we create a global instance of our main game, meaning we can access world data. We can access a global instance of world data, and let's actually go inside world data and player data. So we're basically setting a component state of player data to walking left or walking right when the controller buttons are pressed. And inside our player, if it is walking left, we're just walking, changing the position to be minus something, so it goes to the left, or plus something when it's plus speed, when we want it to go to the right. Okay, but we want the position to go back to idle when we take a cursor off pressing it. So let's go back into our controller button widget this time, inside widgets, and inside on tap up, where we have s pressed equals false, we will do we'll set every time when we press and the button goes back up, we want a component motion state to be set back to idle. So you know how to do that. Global game reference dot instance dot game reference dot world data dot player data dot component motion state equals to component motion state dot idle. Right, let's hot restart our app. Now let's see. Okay, cool. Now that's actually working. You can move left. You can also move right. Now the player's actually stuck in the top. That is because let's go here. Okay, the position defaults to vector to 0 0. So x is 0, y is 0, and of course when x is 0, we're going to be at somewhere in the left, the leftmost side, and y is 0 in the topmost side. That's why our player is being here. So let's actually change that, just so that it doesn't look too odd. Vector 2 here, the x can be something like 100 and y 500. So 100 pixels from the left and 500 pixels from the top. Let's not reload this. And okay, right, now our player's somewhere in the bottom. Cool. Okay, now let's work on actually flipping our player along the x-axis when we're walking to the left. Right now it's just doing a moonwalk, right? Okay, now let's work on actually flipping our player along the x-axis when we're walking to the left. Right now it's just doing a moonwalk, right? So let's first transfer these if statements inside a function. Let's call it movement logic. Let's call movement logic here. Now our update function is a little less crowded. Right, now let's comment everything. Moving left, moving right. Right. So here, let's just do, we have a function called flip horizontally around center. So this does what you think it does. It just flips our player horizontally along the center. Let's actually not do this here, and let's do it in the onload. So it'll start off as being flipped. So yeah, the sprite is flipped. So we really just want to do this when we are walking left. So yeah, easy enough, right? We just have to put this inside here. Walking left, save it. So let's move right a little bit. But yeah, nothing's ever that easy. So something's wrong. It does that. And if we were facing left, we're moonwalking to the right. So everything's broken. So to keep track of where the player's currently facing, let's create a bool is facing right. I'd actually created this before. So this bool is facing right. Let's initialize that to true. Okay, and we only want, while we are walking left, the problem is that it's constantly flipping it, right? But we only want it to flip if the player's facing right. So is facing right, flip horizontally around center. Now we'll change is facing right to false. So it's a one-time thing. And same thing here. Let's copy this. Now, if it's not facing right, right? So if it's not facing right, meaning it's facing to the left, do this and change is facing right to true. Let's reload everything. Yep, so yeah, that's what we wanted. It's working. As of now, the player walking animation plays constantly, even when the player is technically not walking. Let's make it so that it plays the idle animation when the player's in the idle component moving state. As of now, the player walking animation plays constantly, even when the player is technically not walking. Let's make it so that it plays the idle animation when the player's in the idle component moving state, motion state. So we have a sprite sheet here. It actually deletes everything that we have regarding the animation here. Okay, cool. So we have two sprite sheets. One is the player idle sprite sheet and the other is the player walking sprite sheet. Now inside of our player component, let's late initialize to. So sprite sheet, player walking sprite sheet, and let's duplicate this down. So shift alt and down arrow key and player idle sprite sheet. Let's initialize this here. We did so because we cannot exactly do it here, because when we're initializing sprite sheet, we need image, and to load an image we need to use flame.images.load, which is an asynchronous function, and of course we cannot do that in this environment. So we are going to initialize it right here. So player walking sprite sheet equals sprite sheet, and load an image. We'll just do flame.images.load, and here we'll pass in our relative path to our player walking sprite sheet. So this, let's fix the slashes here, and since this looks inside the images directory, we can just remove this and await this. Right, now let's actually, since we'll be using this multiple times, let's create a final called final vector2 player dimensions equals vector2 6060. This is the source size of player sprite in the sprite sheet, or we could do vector2 dot all 60, and let's also define the step time final double step time equals 0.3. Okay, so for the src size, let's pass in player dimensions. Cool. Now let's paste this down. So select this and click on shift, hold shift and alt, then click on the down arrow key. So yeah, and now let's initialize the player idle sprite sheet, and we'll change walking to idle. Okay, now let's create the animations. Just like we late initialized two sprite sheets, we're gonna late initialize actually we're not gonna late initialize this. Let's just do sprite animation walking animation equals player walking sprite sheet dot create animation. The row is 0 and step time is step time. And we get an error here because we cannot exactly use this in the initializer. So let's just mark it late, which magically fixes all of our problems. Again, let's do sprite animation, idle animation. Oops, spell it wrong here. Make this as player idle sprite sheet. Dot create animation, row 0, step time, that. Cool. Now we have two animations. We'll selectively play this depending upon what the player's doing. So if the player's moving left, we'll change the animation to be walking animation. Same, we need to do the same if the player's walking to the right, walking animation. And let's actually, give a default value in the on load. Let's give the animation as idle animation. So when it initially loads, it's not doing anything, but then if it's walking, it's gonna play the walking animation, right? And then now we also have to check if the component motion state is idle. So let's check if component motion state is idle. Animation equals idle animation. So yeah, then yeah, let's actually run this and see if it works. Yes, it does. So when we're not doing anything, it shows the normal animation. When we're walking, it shows a walking animation.